Hello, Big Reds. This is part four. The exam's a little longer than normal tests. We have some few more notes this time. So please take notes on this stuff. All right. So in no particular order, we'll start right here with a parallelogram. They tell you the measure of angle ADC is 81 degrees. ADC, we're talking about this angle. ADC is right here. This is 81 degrees. We want to find the measure of angle ABC. Now in a parallelogram, the opposite sides are parallel. That means these opposite angles are going to be congruent. So this is ABC is also going to be 81 degrees. Okay. One of the things that you're going to have to know for the exam is know all the properties for a parallelogram, a rectangle, rhombus. So it will be multiple choice questions about these, knowing about their diagonals, the sides, the angles, all of that stuff. So you need to know all of those. Study the properties for those three. Make sure you write that down. All right, going on. Speaking of parallelogram, here I have a parallelogram drawn. It may not be perfect, but we want to solve for x and solve for y. So when we're solving for y, what we do, we know that all the angles in a triangle add up to 180 degrees. So I can add these two together. I have 105 plus 27, which will give me 132 degrees. I'm going to subtract that from 180 degrees, and I'm left with 48 degrees. So the measure of angle Y is going to be 48 degrees. Now, in a parallelogram, as we were just saying, the opposite angles are congruent, so angle X is going to be 105 degrees as well. Okay? There's several other ways to solve it, but that's one way. All right, now again about parallelogram. We want to find the fourth vertex for the parallelogram. So you can see this is the point 0, 0. This is a point 2, 1. This is a point 1, 2, and you want to graph this. So if you look at my slope here, a slope is going up 1 over 2. That has a slope of 1/2. So the opposite side is also going to have a slope of up 1 over 2. So from this point, I'm going to go up 1 over 1, 2, and put a dot. That would be at the point 3, 3. Now if I connect them, this side is going to have the same slope as this side. This side is going to have the same slope as this side. So opposite sides are congruent. So this would be your answer. Okay, now I have several questions with this graphic here. We have a regular hexagon. Assume it's a regular hexagon anyway. It says the side length is 18. So I'm going to label the side length as 18 and a radius of 15. So I'm going to put a point in the center of the polygon, and I'm going to connect all the vertices to the center point right here. When I do that, I know that this radius is going to be 15. Doesn't matter which one I put it on. They all should be congruent. All right, now it's to ask us for the sum of the interior angles. Sum of the interior angles is given by the formula n minus 2 times 180 degrees, where n is the number of sides. So this has 6 sides, so I take 6 minus 2 times 180, which will give me 4 times 180, which would be 720 degrees. That's your answer for this one, sum of the interior angles. Sum of the exterior angles is always going to be 360, no matter what type of polygon we're talking about. Sum of each interior angle. Well, here's the key. We take the sum, which is 720, and we have to divide it by, there are 6 angles, and we're assuming all those angles are congruent. So we're dividing it by 6. Each interior angle is going to be 120 degrees. All right, now, the area, that's going to be a little more tricky. Okay, so first of all, what I'm going to do is I'm going to divide this triangle in half, assume these triangles are congruent, to draw in the apothem. Remember, this is called the apothem, or the height of this triangle. I'm going to take the 18, divide that in half, and get 9 here. And so I'm going to use Pythagorean theorem to figure out the height of my triangle. So I'm going to take 9 squared plus b squared is equal to 15 squared. Or 81 plus b squared is equal to 225. I subtract 81 from both sides. When I do that, I get b squared is equal to, oh, let me see, I think that's 144. If I made a mistake, please let me know and I'll give you a donut point. Take the square root of that, and I get b is equal to 12. So that means this height is 12. Well, to get the area, I have to take the base of the triangle, which is 18, multiply it by the height, which is 12, apothem is 12, divided by 2, because in a triangle we have to divide by 2. Then I multiply it by, there are 6 triangles, and that's how I get my area. So let's see, what is that going to be? Let me grab a calculator very quickly, and I can figure that out. So I take I'll clear this out right now. I'm going to take, let's see, what is this? 18 times 12. I'm going to clear this out here. 18 times 12 divided by 2, multiplied by 6, and I get 648 square units. Okay, that's the area of this regular hexagon. All right, next, going on. All right, now we want to figure out the area and perimeter of this triangle. So first of all, we have to figure out the lengths of the sides, right? Well, if I can count right here, this is 1, 2, 3, 4, 5, 6, 7. You don't have that paper, but you can graph this on graph paper. Just pause it, graph this, okay? Then, to get the length of the side, I'm going to use a right triangle. This is going to be 2 units. This is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to use Pythagorean theorem. 8 squared plus 2 squared equals c squared. 64 plus 4 equals c squared. 68 equals c squared. I take the square root, and the square root of 68 is approximately 8.2. So length of this side is 8.2. All right, now, actually I don't even, I want to find the area and perimeter, that's right. So then I go up here, I look here, I have go up 1, 2, 3, 4, 5, and I go over 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do another Pythagorean theorem. 8 squared plus 5 squared equals c squared. So that's 64 plus 25 equals c squared. Add this together, get 89 equals c squared. Take the square root of 89. And the square root of 89 is 9.4 approximately. Okay, now to get the perimeter, I have to add together all those 3 sides. This is 9.4, remember? So I take 7 plus 8.2 plus 9.4. Sorry, I'll move this over a little bit. And I add these together, I get, let's see, 17 and 7 is 24, 24.6 units approximately. Should be approximately. Okay, now to find the area, I take base times height divided by 2. Well, the base looks like it's 7. The height is the distance straight up and down. So I take this top point, go straight down here, count 1, 2, 3, 4, 5, 6, 7, 8. So 7 times 8 divided by 2, which that's going to be 56 divided by 2, which is 28 square units. All right, going down to this rectangle right here, if I want to find the area and perimeter of the rectangle, I'll do the same type of thing. I know my opposite sides of rectangle are congruent, so I'm going to make my right triangle. This is 2, this is 12, this is 1, and this is 6. So I do Pythagorean theorem. 2 squared plus 12 squared equals c squared, and I end up with, skipping a couple steps, c is approximately 12.2. Same thing right here with a 6 and a 1. I take 6 squared plus 1 squared equals c squared. I skip a couple steps. C is approximately 6.1. Now, to find the area, I take 12.2 times 6.1, and I get approximately 74.4 square units. And for the perimeter, I add 12.2 plus 6.1 plus 12.2 plus 6.1. I could also multiply 12.2 times 2 is 6.1 times 2, add them together. And I get 36.6 units. That's the distance around the perimeter. Now, if you are in regular geometry class, that is the rest of your exam review. If you're in honors, you have one more video to watch. Go Big Reds and good luck on your exams.